Okay, so for today's lesson, we're going to talk about the inverse of trig functions. But before we start doing that, we're going to talk about the review of what we did the other day. So a revision of what inverse functions are. So number one is a function is invertible. In other words, a function, you can find an inverse for it if it passes the horizontal line test, which means that it has to be one-to-one. So by horizontal line test, use this as an example. You have a straight edge. If you go up and down, if for every y value here, if it touches the x twice, then that function is not invertible. So this one here, it doesn't pass it because this point and this point would make it not one-to-one. And now for this example, if you scroll up and down like this, it will for every y value, there's only one value of x. That means this will pass the horizontal line test, which means this function is invertible. Okay, so the main thing that we didn't really talk about, but the main focus is if you restrict the domain of a function to make it one-to-one, it will work. So remember the other day when we talked about the example of y equals x squared, if you restrict the domain to only this side, that means you can invert this function, which is passes the horizontal line test. But if you do it, and then you find that this is the inverse of this function. Okay, so a function is one-to-one, and you found inverse. That means f negative 1, that is the inverse of f. Okay, that's the notation that we use for inverse functions. Okay, the domain of f is the range of inverse of f. Okay, the domain of inverse of f is the range of f. So I'm going to highlight this or underline this so it's obvious to you that what are the switches that we have. So I'm going to repeat that. The domain of f becomes the range of inverse of f, and the range of f is the domain of inverse of f. Okay, so the next thing we covered the other day was talk about how do you find the inverse of a function. So the first thing you should do, switch x and y, and then solve for y. So that means y is equal to this function made out of x's. Okay, once you found that function, you want to check the solution to see if it comes out as the inverse itself. So that means f inverse of f of x. So this is a composite function. If this is equal to the inverse of f, and this equals x. For both of these situations, that means this function here is exactly the inverse of f. So it means if f of inverse of f is equal to x, and inverse of f is equal to x, again, this is all algebra. That means if it actually comes out as x, that means you have found the inverse and you're done with this question. Okay, so for today's lesson, we're going to talk about the next section, which is 4.7, the inverse trig functions. So the first example we're going to talk about is y equals sine of x. Okay, so this is, I drew up the inverse function of sine of x. And if you look at this, using a horizontal line test, this doesn't pass it. Okay, so as you can see, it's not one-to-one. So that means if we want to find the inverse of sine, we have to restrict the domain. Okay, so we have to find a way to break this up and to make it one-to-one. So what we usually do here is keep close to the 0. So if you erase this part and this part, and then now this function here is one-to-one. Okay, and now that we're restricted to it, now this is going to be pi over 2 negative and pi over 2. Okay, so now that we're restricted to it and this passes the horizontal line test, that means we can find the inverse. So the inverse of this function, it looks something like that. So that is the inverse of sine. So the notation that we use here is going to be called sine to the negative 1 of x. That just means it's inverse of sine, or we can call it arc sine. Okay, arc sine. So in that case, arc sine is also the name for the inverse. Okay. So let's talk about the domain. So since we're restricted the domain from negative pi over 2 to pi over 2, that will be my domain of sine. So negative pi over 2 to pi over 2. Make sure we use square brackets. Okay? And then the range for this function, as we recall it, is going to be between negative 1 and 1. Okay? So as we do for the inverse, we follow the same procedure. Switch it around. So this one becomes negative 1 to 1. Again, square brackets. Just make sure. And then this one would be negative pi over 2 to pi over 2. Okay? So when we use something like this function here, let's just call this y is equal to this. Okay? That means the only thing we can put into the sine of x, and the x value, you can only put in a ratio of the legs. Okay? then what you get for an output, you get an angle. So arc sine, put in something, a ratio, you get an angle out of it. Okay? So let's come back and kind of think about the unit circle. Okay? So if you think about negative pi to pi over 2, essentially looking at it as quadrants 1 and 4. But remember, because quadrant 4, you're going in the negative direction. That's what we have. This is the positive quadrant, and this is the negative quadrant. Okay? So keep that in mind. So here's an example. Arc sine of negative 1 over root 2. Okay? Negative 1 over root 2 is a common angle for it's a 45, 45, 90 triangle. Okay? So if you look at this, you have arc sine of negative 1 over root 2 is equal to theta. Okay? So this is a ratio, this is an angle. So you can rewrite this function as sine of theta is equal to negative 1 over root 2. Okay? Because we know this part here is a negative, that means this is definitely in the fourth quadrant. Okay? So your angle is going to be a negative angle. Okay? So in that case, if you come down this way, negative 1 over root 2 is synonymous with negative root 2 over 2. That's a 45-degree angle. But because we're in quadrant 4, we're going in the negative direction, the answer is going to be negative pi over 4. Okay, so that is an example. Okay, we'll go over more of this later. Okay, the next part here, let's talk about the y equals cosine of x. Okay, as you can see, this is what cosine of x kind of looks like. So again, it doesn't pass the horizontal line test, so it's not one-to-one. Therefore, we have to restrict the domain to make it work. Okay, again, we want to stay as close to 0 as possible. So if you look at this, this doesn't work because when you add 0, it's not one-to-one. So that means if you erase this part of the graph and only look at this part. So in that case, let's our domain be 0 to pi. Okay, so if you test this out, this passes the horizontal line test, therefore we're good to go. Okay, so again, if a function is one-to-one, you can find the inverse by drawing this line. Okay, so that means what we have here is our graph is going to look something along the lines of that. Okay? Whoops, that's not right. Okay, so that means, whoops, something like that. Okay, it's not a very good drawing, but that's what it kind of looks like. It reflects across that function over there. Okay? Well, I should fix it. Okay? Looks something like that. Okay, so that's my function. Because we've restricted the domain, now the domain here for cosine of x is between 0 and pi. Okay, and then that made my range here is going to be negative 1 to 1. Okay, against square brackets. Okay. By the way, I am saying that this domain and range stuff is strictly just to get this for inverse of sine, and the same thing for inverse of cosine. Okay, the domain and range for sine, as always, is going to be negative infinity to positive infinity, all real numbers. And my range is negative 1 to 1. Okay, this is just to set things up so you can see the inverse of sine. Okay, so the same thing works for the same for cosine here. So that means my domain here is going to be negative 1 to 1. Again, square brackets. Okay, and my range here is going to equal 0 to 2 pi. Okay, as I mentioned before, this thing, arc cosine is what we call it. So arc cosine, that's how we pronounce it. So that means whatever you put into x, it's going to be a ratio. Whatever you get for y, that's going to be an angle. So that switches around. Okay. Now, to think about the inner circle, again, same thing. So 0 to pi is quadrants 1 and 2. So in that case, my graph here is going to be somewhere between here and here. Okay? So in quadrants 1, it's going to be positive, and cosine is negative in quadrant number 2. So that means if you get a negative number in here, you're going to be getting a number. You should get an angle in quadrant number 2 because cosine is negative in that quadrant. If you get a positive number like this, arc cosine of 1/2, you should be somewhere in the first quadrant because cosine is positive in that quadrant. Okay, so that means, again, we can rewrite this as cosine of theta is equal to 1/2. Okay, so this is also a good angle. Cosine of theta is equal to 1/2. Okay, if you remember your unit circle, theta is going to equal pi over 3. So that means, double check your answer. Is theta pi over 3 within 0 to pi. If it is, then you're good to go, okay? And you can do a double check for this one as well. Is negative pi over 4 within negative pi over 2 and pi over 2? Yes, it is. That means we have the right answer, okay? So remember, x, what you put in for arc cosine, arc sine, for any of the inverse trig functions, x is going to be a ratio. And what you get out of it is going to be an angle, okay? So in a little bit, we'll go through y equals arctan, and then after that, we'll go through a couple examples, and that's all for today, okay? See you in the next video.